Hello, everyone. We are back with another round of Turing Mock interview series. I'm Fazil from Pune, India. I am a full stack engineer at Turing, and I have 5 years of experience in working with JavaScript, Node, Angular, React, MongoDB, SQL, and blockchain. Today, I will be interviewing David for the role of an experienced MLOps engineer. Are you guys excited? Let's get started. So first of all, David, how are you doing and how has been your day so far?
Everything is great, thank you. How was your day?
Yeah, it has been great, a great day so far, and I'm excited for this interview.
Me too.
So, yeah, all right. So my first question to you, David, would be to introduce yourself to the audience by talking about your background and your professional experience.
Thank you so much for the invitation, first of all. Hi, I'm David. I'm from Armenia. I have more than 5 years of experience in IT, machine learning, artificial intelligence, and data science. I'm passionate about the field very much, and I've tried my hand on a bunch of projects, starting to applications of artificial intelligence to drug discovery to cybersecurity.
Superb, superb. So David, your background looks amazing. And I've also checked your resume, and believe me, it's a perfect fit for this role. So moving on to the next question. So David, I can see that you worked so hard to reach where you're today. So can you talk more about some of the interesting MLOps projects that you have worked in the past?
Yeah, I would like to mention two particular projects that I'm really proud of. One was related to the applications of machine learning and artificial intelligence to loan scoring in the banking sector. And the other project was related to the applications of machine learning and MLOps for forecasting stock markets.
Okay, sounds interesting, very interesting. So now let's talk about MLOps in detail. So David, would you like to talk about some of the steps in a basic MLOps pipeline, and maybe you can link it to one of the projects that you've done in the past?
Sure, of course. So we typically start the MLOps pipeline with the data collection and data ingestion. So bringing example on the project that we've done for several customers, which were banks in our country, we were collecting the data by connecting to their APIs. And so then the next step that followed in the pipeline was the data pre-processing with data cleaning and feature engineering. So the data was typically it looked very much like each other. So most of the features were overlapping. However, there were a lot of differences too, and a lot of intricacies. So there was a lot of data cleaning and data pre-processing that we had to do and implement that in the pipeline to do that automatically and not to do the manual labor again with the same customer or with when the customers changed and the types of data and the underlying features. So the whole process was automated for us. Then we moved to the model training and model selection phase, where we tried a bunch of models, starting from classical machine learning to deep learning and the different variations of neural networks. We built a lot of hybrid models to perform better on the customer data set in each particular time window. And for different customers and different time windows, these models were different, and they were even different for the same customer, but for different loan products of the same customer. And automating all of these steps for the model training and model selection was really crucial to be able to efficiently deploy the MLOps pipeline. Then once we were good enough with the results and we were satisfied with our results for the model, we moved it to the model validation and model testing phase. We were finally generating the predictions for the incoming data of the customer, and that was the deployment phase. And finally, one of the most important critical parts of the MLOps pipeline is the model monitoring, because you might be really proud of your ML model that you have built, but with time, when the data changes, the data drift occurs, the distribution of data changes, your customer gets their product promoted to new markets and new data is coming in, your model might not be performing that well. Also, there is the seasonality problem that might affect your model. So the model monitoring stage of the MLOps pipeline was really crucial. And then I would look at this not as a linear pipeline, but rather as a cycle. From the model monitoring, we moved back to data collection, because let's say some of the features that we've built our model on were not collected anymore by the customer because the bank wanted to make the process of loan applications easier for its customers, and they have removed some of the necessary application for loan, and thus we lost some features that were important for our model. So we need to retrain the model, do some new feature engineering, then retrain the model, and then repeat the cycle again.
Okay. Okay, super interesting answer, David. So we will move on to the next question. David, why do you think that we should be packaging ML models?
Yeah, I think packaging machine learning models saves us from a lot of headache at different phases, from the creation, configuration, experimentation to tracking different experiments, and most importantly, to be able to have reliable performance of the model on different machines and on different computational environments. So I think that's these are the main reasons why packaging models is really crucial.
Absolutely, absolutely. So now that we have talked about why packaging models are important, David, would you like to talk about what are the different ways in which ML models can be packed, and how have you done it in the past?
Yeah, so I think one of the most important ways to package ML models is saving models in a Docker image, so that your colleagues on your team and also maybe your customers who will be using the model can actually run them in a Docker container, and that will save a lot of headaches for you don't have to care for dependencies, and the problem that it works on my machine but not on the other machine kind of gets away out of the way. There are also tools like MLflow that help you a lot with the automated packaging, and when running your experiments in MLflow, for example, and there are some other MLOps tools similar to that, you can have your models automatically packaged. It generates the requirements.txt files automatically, lists all of your dependencies, and also the environment that's needed to run the model.
Okay, okay. So very well answered, David. And all our MLOps enthusiasts viewing this video, please feel free to add your answers in the comment section below if you would have answered the same question differently. All right, so having said that, let's move on to the next question. So David, what do you think is the difference between continuous integration, continuous delivery, and continuous deployment?
Yeah. So I think these three concepts are similar to each other, but one builds upon the other, and there are some differences between them as well. So continuous integration is actually part of both continuous delivery and continuous deployment. It basically is a good practice when you commit all of your changes to your code to the main branch, and the good practice can be to do it even daily, as frequently as every day, so that you don't have to wait until a lot of changes accumulate and then you push a big change, and then you care about the integration, whether there would some problems would arise related to the integration. Rather, the changes are incremental and relatively minor, and you're able to track where the problem comes from, if there is any problem in that. So that was the continuous integration. Continuous deployment and continuous delivery are pretty similar to each other. So they basically automate the parts of acceptance tests and deploying to different to staging. The difference, though, is that continuous delivery deploys the models or your software to production manually. So it can be very easy, like just clicking a button, but still you have to do it manually. And in continuous deployment, the deployment to production is automated as well. And I think both have smoke tests at the end, both continuous delivery and continuous deployment.
Super, very well answered. You explained the differences quite clearly, so that was great. So
thank you.
Now let's relate this particular question to machine learning systems. So what do you think are the benefits of having CI/CD pipelines in a machine learning system?
I think the main benefits are quite similar to having the CI/CD pipeline to software, to apply to any software. So I would single out the speed, reliability, and accuracy as the main benefits. So you're able to deliver your new changes and get feedback from the customer at speed rather than waiting for a month or a quarter to then have the next beta release and then the customer provides feedback. Rather, you do it on a daily basis, or it can even happen a few times a day. The reliability is that ideally it should produce clean and identical outputs for each input. And the accuracy is that the human error gets out of the way. And it's very likely to have some human error when you're dealing with repetitive tasks. So you don't have that problem in the automated CI/CD pipeline.
Right. So it's all about speed, reliability, and accuracy. And I'm sure your clients are going to love that.
Yeah, sure.
Yeah. So David, now would you like to talk about what are the different types of tests that you can perform in the MLOps cycle?
Yeah, sure. So I would divide the types of tests in two main categories, like the types of tests that are common to maybe any software system, and then types of tests that are specific to ML and MLOps field in particular. So those general tests, I think, would be like unit tests when you're testing each individual component. And it is good practice to write your code in a way where each component, let's say a function, has a single responsibility. So you can test that function on that responsibility. Then the next maybe level or layer of tests is the integration tests, where you are testing the integration of a few components. Even higher level of aggregation would be system tests, when you test the design of a system by validating inputs with outputs. And finally, there would be acceptance tests at the top of the pyramid. There might be some other types of tests that are common in software engineering, but these four, I think, are the main carcass of the testing pyramid, if we can say so, for the general software tests. As for the tests specific to the ML systems, I think I would divide them into two parts in their turn too. So the first group of tests is related to testing the data, and the second group of tests will be related to testing the models.
Superb, very well answered. So David, you covered the whole 9 yards of testing. So very well answered, I would say. So now I would like to call upon my fellow developers and all the MLOps enthusiasts watching this video. If you think we've missed a question today, please feel free to post them in the comment section below. And if you're looking forward for a job, go to www.turing.com/jobs and apply for the one as per your expertise. Now, moving ahead to the next question, David, what are some of the best practices that you follow while performing testing in an MLOps cycle?
Yeah, so I think some of the good practices would be to tie testing into the development process and to do it as early as possible. And regardless of the framework we use, there are, I think, several good practices to have atomic tests, so to write your code in atomic way. So when creating functions and classes, we need to ensure that they have a single responsibility so that we can easily test them. The second, I think, important thing is when we create new components, we want to validate their functionality, and that would be a great way to ensure reliability and catch errors early on. So I think there is also a practice called test-driven development. So you write tests first and then write the code to test those tests. So you might not take it to that extreme, but at least it's good to have testing that would have the full coverage of your code base. This doesn't mean that you have to write tests for every single line of code, but rather your test should account for every single line of code. That would be like awesome to have full coverage. It still does not guarantee that there won't be any errors in your code, or they won't arise during the production, because you may still have 100% coverage, but your test might not be ideal. So that might be a problem. So you have to take account of that too. I think regression is another important concept when talking about tests. So we want to account for new errors when we come across a regression test, so that we can ensure we don't reintroduce the same error in the future. Also, reusing as much of your code base or your code repository, the central repository where the main functionality is hosted, is also important. Not to rewrite different parts of code for different tasks all the time, but rather to have your code being reused as much as possible. So I think that's another important practice to follow. And this would also significantly reduce your testing efforts for each new project's code base. And finally, I think the automation is another important best practice to follow. So in the event we forget to run one of our tests before committing to a repository, we want the system to be automated so that it would auto-run tests, and we won't end up committing a code that wasn't tested.
Absolutely, absolutely. Thank you so much for such a great answer, David. So, David, now why do you think that we need model store for our MLOps projects?
Yeah, first of all, I think it's important to have all of your models to be stored in one place, because it's really difficult at some point. So once you are, let's say, 6 or 7 months into a project, to collect them from different Jupyter notebooks. And that's a bad practice that happens in many ML teams. So there are just notebooks scattered all over the place, but there is no single model store for your notebook. So there are some tools that provide you automated registry of models. I mentioned, I think, MLflow before, so that tool also provides that functionality, and there are other analogs for that too. And I think another important thing is for your models to be reproducible and production ready. So a good model store would also actually contain all the information and files needed to reproduce the results of a model. Yeah, and it would include the process for the model to be packaged, tested, and ready to be deployed.
Absolutely. Perfect. Very well answered, David. So, David, what do you think model drift is, and what are the different problems that relates to model drift, and how have you overcome them in the past?
Yeah. So yeah, drift and different types of drift actually are a haunting problem for ML and MLOps in particular. So I would differentiate between two major types of drift. So the first one is data drift, and the second one is concept drift. The data drift occurs when your underlying distribution of data changes. So I think I've briefly mentioned in the example of my project with the bank customers, when they were introducing new loan products, or they were changing the requirements for the loan product, they were entering new markets, or they were introducing products for a new age category, or new loan products for specific specializations, let's say IT or whatever, and the data distribution actually changed significantly. So if you are applying a model trained on a different data with a different distribution to make inference on the new data, that's actually a great problem, and you need to have a number of data drift tests in place that would actually detect the data drift and warn you in advance of that. The second part of drift that I think is also very important to take account of is concept drift. This is the situation when some of the statistical attributes of your target variables change, or the relationship between your independent and dependent variables changed. Basically the relationship between your X and Y changes. So I think a good example of that can be the lockdown, which all of us, maybe all over the world, can relate to and experienced a couple of years ago. Maybe for some countries it was the memory is even more fresh than 2 years ago. So us are using credit cards, but there is a different pattern of using credit cards. And during the lockdown, when most of us were locked in home, and it was even difficult to go and take cash from ATM machines, the usage of credit cards actually spiked. And if you had a model, let's say a fraud detection model for credit card usage, then your model would say that it's a completely different pattern for your customer during the lockdown. So you should be aware of other changes and the relationship between your independent variables, which in this case might be the income level of a person, the age, the mobility of a person or even the education level of a person, and your target variable would be their credit card usage pattern. So that relationship actually changed a lot when there was a new force introduced into the equation. And this was the extreme example, but there are like day-to-day examples that are milder in their magnitude, but you still have of them. And the drifts can be gradual, they can be abrupt, and you should also have different tests suited for different types of drifts.
Superb, superb. Very well answered, David. So now that we have talked about data drift, let's talk about detection of data drift. So I'm sure you're aware of the use of statistical methods versus statistical process control for data drift detection. So would you mind talking about it?
Yeah. So I think statistical methods the arsenal of statistical methods we can deploy to data drift is really huge. It can be as simple as looking at the mean and standard deviation of the data for a specific time window, and it can go further to tests like Kolmogorov-Smirnov tests or other tests that can detect whether the data comes from different distributions or whether it is from the same distribution. And statistical process control is actually important, but it also has the requirement to be able to provide the labels of the samples. In some practical issues in production, the labels are not readily available. Let's say with again, going back to that loan application example, we don't know the label, whether it would the loan would default or not until, let's say, some months or even years. So in those cases, we had to use statistical methods instead of statistical process control. And in cases where you have your labels available, let's say going back to the credit card example, when let's say there is a manual or automated process of verifying whether the transaction was made by the actual cardholder or not, then you have the labels, whether it was fraud or not fraud, and you can also deploy the statistical process control in that case.
Perfect. Very well answered, David. And that was the last technical question for today. So now, David, would you like to help our MLOps enthusiasts and viewers of this video about resources that you would like to propose to them if someone wants to start learning MLOps from scratch?
Yeah, I think there are myriads of resources online, and that's the great part about learning MLOps these days. It actually depends, of course, on the taste, and your way of studying. But I prefer both online courses, video courses, and reading books. So I bring just one example on that and the other example on the other. So there is a great course on Udemy called Deployment of Machine Learning Models, and I think that course does a great job of walking you through different steps and all the ways to arrange your code base and different types of files and different pieces of software that you need for testing, automation, etc. So that's a great course. Check it. Deployment of machine learning models, and of course there are similar courses on Coursera and other platforms as well. And there is also a great book called Practical MLOps. I think it was published last year, so it's really fresh, and it contains some of the description of some of the best practices in the field. So that's an enjoyable read too. Yeah, these are the two resources I would recommend to start studying MLOps.
Superb, superb. All right, that's it for today, David. So thank you so much for sharing such valuable information with us today. I would say you're such a great developer, and it was really nice speaking with you.
Thank you so much for the invitation. I really enjoyed the interview.
Great. So to everybody else watching this video, thank you so much for tuning into this Turing mock interview series and viewing it till the end. And I hope you've enjoyed it as much as we did. We will be back with many more episodes covering different tech stacks and languages. So if you are looking out for some specific mock interviews, please drop in your suggestions in the comment section below. And don't forget to give us a big fat thumbs up if you like this video. And if you want to get notified for such future videos, subscribe to our channel and hit the bell icon if you haven't done it already. You can also follow Turing on Instagram, Facebook, LinkedIn, and Twitter for more frequent updates. The links to all our social media handles are given in the description below. I'll see you again in the next mock interview. Till then, take care, stay safe, and happy coding.